Hey, what is going on, guys, and welcome back. We are starting section 4 in part 3. This will be the final section in this chapter. It's been a couple of days since the previous video, but I sort of was rethinking about how I wanted to do content moving forward pertaining to this course. And I think what I'm going to do is instead of doing the small 20 to 30-minute videos, I think it might be better for us just to keep pace with the course if we were to switch to doing long form videos in which each video we will go through one section at a time per chapter. So we'll have one video where we cover through, for example, if we were starting part 3 right now, then this video would have been a full hour or more in which we just go through section 1 on loops and condition, and we go through the entire material, do all the exercises in this video. And then the next video will be covering all of section 2, then the video after that will be all of section 3, and then the video after that will be covering section 4. So I think that's what we're going to switch to moving forward. If anybody has any feedback on that, just let me know in the comments below and we can maybe do some sort of hybrid. But I think that might be a better way to do content and to, continue covering this course moving forward. But instead of doing these shorter 20, 30-minute videos, I think I'm just going to have to dedicate a little bit more time to recording to be able to, do the whole entire section in one go. And instead of doing 20, 30-minute videos and breaking each section into multiple videos, I think this way moving forward might be the way to go. So this video, we're covering section 4, as I mentioned at the beginning. Section 4 is on functions. Finally, we get to learn how to write functions in Python. This is one of the most important skills and knowledge to have. Functions are so crucial to programming. This is across programming in general. In every language you will ever go through, Java, JavaScript, TypeScript, Python, C++, C, C Sharp, etc., etc. Functions are so crucial in being able to write really good programs that do a lot more things. And they just help expand your program's abilities so much more. So this is very important. In the past, somebody asked me, at what point should they start trying lead code problems? And I think after section 4 in part 3, right, learning how to write functions, I think from here, if anybody wants to go try doing lead code, doing HackerRank, CodingBat, etc., those kinds of websites where you go through uh, various exercises and challenges in the language that you want to learn and take on those exercises to prepare for interviews, for job interviews and whatnot. I think after section 4, this section we're about to cover right now on defining functions, I think you can start to be able to take on some of those easier problems on LeetCode, on HackerRank, and those kinds of websites because the easier questions tend to be more logic based. So and solutions tend to want you to use functions, or just the easiest way to solve them will be to use functions. So once you learn how to write functions in Python, I think you can go ahead and start doing those problems on LeetCode. And don't worry about time complexities. Don't worry about how to write programs that run really, really fast and big O notation and all that stuff. You don't have to worry about that at any point during this introduction to programming phase of the course. I think once you go to the advanced section, they're gonna go through data structures and stuff like that, in which you might start learning about time complexities. I'll have to go through and look at the content down here to see if that's true. But in part 1, you don't have to worry about anything that advanced. So once we do this section, learn how to write functions, go give those lead code questions a try, go give those HackerRank questions a try. I think HackerRank might be even a little bit better on that stuff, on the logic-based questions rather than the time complexity questions. So yeah, I think this is probably one of the most important sections in the entire course so far. So we're gonna get to learn how to write functions in here. So again, like I mentioned before, we're gonna go through the entire section. I'm gonna read everything here. I'm gonna do every exercise that we see. There's a couple of them in here. And then at the bottom, I'm not gonna put this in the video, but there is a feedback quiz. You can take this on your own time. I think again, I've recommended doing this in the past. Just submit that feedback for the university to be able to use that to improve the course moving forward. All right, so let's get started defining functions. The learning objectives for this section are as follows. After this section, you'll know how to write and call your own functions. You will understand what is meant by the argument and the parameter of a function, and you'll be able to define parameters in your own functions. And again, all this stuff is so crucial in expanding your abilities to write really good programs, not just in Python, but in programming in general. All right, we have already used functions such as the length, print, and input in our programs. Right? These are all functions that are built into Python. Right? The length function returns the length of a string. The print function prints something out to the screen, right, to the console. And the input function is what tells Python to record what a user types into your program. These are functions built into Python, and so they are always ready at our disposal, no matter which environment we're programming in. However, it is also possible to define your own functions. The function definition. Before a function can be used, it must be defined, right? We have to write, right? In programming, again, it's very procedural, right? You have to tell you're almost telling you not almost you're telling the computer what to do, right? You're telling the environment what to do. So when you're defining a function, you're basically writing the formula on what it's supposed to behave like, right? If it takes in an input, what does it do with it, and things like that, right? You have to write all that out first, and then you can be able to call that function or to be able to use that function. Any function definition begins with the keyword def, right? Short for define. Then comes the name of the function, followed by parentheses and a colon character. So we've seen colons when we're using loops, when we're using conditional statements, right? If else statements, right? So the colon is very important in Python. This is called the header of the function. After this, indented, just like while and if blocks, comes the body of the function. For example, the following code defines the function message. So here we have the function header, we have the define keyword, right? So we're telling Python define this function called message. Then we have our opening and closing parentheses followed by the colon, and this indented, right, one tab space away from the leftmost edge of our text editor, right, of our programming environment. We have the print function. We call the print function and we pass in this string. This is my very own function. If the program above is executed, nothing seems to happen. This is because the code in the body of the function is only executed when the function is called. Calling a function is as simple as mentioning its name in your code, adding a function call to the end of the above program like so. So again, the function header, we define this function called message. The body of the function tells Python to print this string. This is my very own function. And then down here, we call that message function. So you call a function by writing its name followed by an opening and closing parentheses. Results in a printed statement. This is my very own function. When a function has been defined, it can be called multiple times. So again, we define this function called message. The body of the function tells Python to print this string. This is my very own function. And then down here in our program, we're calling that function 3 times. So Python is printing, right, is going to print out what's inside the body of our function 3 times. This is my very own function, printed once, twice, and 3 times, right? So doing this is the same thing as just writing this print statement by itself 3 times. But it's kind of another way to think about it. This is one of those side notes that they put sometimes in the section material, testing your own functions. From now on, the majority of the exercises on this course will ask you to write your own functions. When a program consists of only functions, executing it doesn't seem to have any effect. The following code doesn't print out anything, even though there is a print statement. So we define a function called greet, has an opening and closing parentheses followed by the colon, and the body of the function just prints hi. The reason nothing is printed out is that the code within the body of the greet function is only executed when the function is called, like what we just covered up here. The main program below the function should contain appropriate function calls so that the program can be tested. In fact, Python treats all code that is not within the function definitions as part of the main function, which gets executed when the file itself is evaluated or executed. So let's add a function call. Again, we define our function here called greet, which prints hi, and then we call greet down here. All code not within the function definition is part of the main function of the program calling our function, right? You can also think about this when we're going through loops or when we're writing conditional blocks, right? Anything that's written inside of the conditional or inside of the loop is lives in its own block, and then anything outside of that lives in the greater uh, function. I mean, the greater Python text file that gets executed. On this course, the automatic tests that are run on the exercise files require an empty main function. No commands should be left in the main function of your solution. That is, any code that you yourself use for testing must be contained in a specially defined if block. So we define our function as normal, then we have to use this if block. So which is basically what our main function is going to be, and then we call our function here. So we're not going to call it outside of this if block moving forward. And you will see it in the exercises below. It'll be predefined for us. Any code left outside the above block causes an error. So we define this function called 7brothers. It prints Peter. And then we call 7brothers, and that's going to throw this error here. Python editor test main program OK. The code for testing the function should be placed inside this if statement, or this if block. The following row should be moved, and then it tells us to move the function call to be inside of this if block. The purpose of this is to make sure that your solution gets tested on a clean slate, as the tests often check what your function prints out. It is worth noting that the test will not execute any code from within the if block, so no code that is needed to fulfill the requirements of the exercise should be placed within the block. So we define our functions outside of this block, and then we call our functions inside of this block, is basically what this part is saying. So here we have an exercise called 7brothers, and we're told to please write a function named 7brothers. When the function is called, it should print out the names of the 7 brothers in alphabetical order, as in the example below. And we've covered a very similar exercise in part 1, right? One of the first exercises we went through. So you can go back and take a look at that if you click this link here. Right, it'll take you to that exercise which we covered. Right, yeah, it was the first exercise we ever covered. So, all right, so anyways, we're told here to write our solution. So we're going to define a function called 7brothers. I'm just going to copy the name here. Going to use the define keyword, define 7brothers, opening, closing parentheses, followed by the colon. And then I'm going to copy this, put it here. Actually, in fact, we can go ahead and print all this, right? Copy that and just paste it there. Make sure we indent correctly. Make sure that these are all in alphabetical order. They are. And then we just comment this out. We just comment this out. If you press, let me undo that. If you press Control plus the forward, I have a 60% keyboard, so it might be a little different for you guys. But if I do the Control and if I hold function Control and the question mark button on my keyboard, or the forward slash, because it's a 60% keyboard, so that's kind of combined. But it comments out my code, or it uncommented commented out code. So this is that if block that we need that will allow us to then call our function to be able to test it. So if we run this, there we go. It prints out the names of the 7 brothers in alphabetical order. If we click test, we should pass all the tests. We do. We can view the model solution, which is going to be exactly the same thing that we written here. Let me log in. Okay, so we're logged in, and you can see here they define a function called 7brothers. Inside, we tell Python to print the names, and we list them in alphabetical order. Then we have this if block here that checks if the name is the main, right? This is our main function block, and here we call the 7brothers function, and it's going to print all these names out as we have defined here. All right, so that's the first exercise. Okay, now we're going to learn about function arguments. Functions often take one or more arguments, which may affect what the function does. For example, the built-in Python functions print and input take as argument or arguments the text that is to be displayed. So here in the print function, right, we pass this string, hi, right? This is an argument. We're telling the print function to print this out. This is what we want the function to print out the string hi. Here we have the input function. Same thing, it takes an argument, right? This is a string argument. And remember, we can wrap this into with the integer function that will convert our input into an integer. So when we print, so the input function takes in an argument, the print function also takes in an argument, right? So here we're going to print the name. It was mentioned before that the terms argument and parameter are often used to refer to the same thing. The distinction is that while argument is used with the data passed to the function when the function is called, inside the function, the arguments are assigned to variables called parameters. So approximately, when the function is called, we call the passed bits of data arguments. But when we are defining the function, we call them parameters, right? So this may seem like a futile semantic distinction, and to make things even muddier, now all sources follow this definition. On this course, we attempt to keep the distinction clear. However, as knowing the correct terminology will help you understand other sources besides this course material. Let's define some functions that take arguments. In the function definition, the parameters are defined with the parentheses after the function name. So let me just reiterate here what this is saying. Let's go to our Python playground. Let's say, for example, we'll define this function called print name. It's going to take in a name, and then here we're just going to print name. Then we're going to do the same thing. If name is equal to main, then we're going to call print name, and I'm going to pass my name. So what's happening here? So what's an argument and what's a parameter? So what this is saying, when we're defining a function, right? So when we're defining a function, we call this, right? This, for example, here we're using the name to define our parameter, right? When we're defining a function, this bit of stuff written between the parentheses is called a parameter. But when we're calling the function, when we pass that value, that's called an argument. That's basically what this section is trying to define. When we're defining a function, we refer to the stuff inside the parameters, the parentheses, as a parameter, right? This is what the function is going to use to do stuff with it. It's going to do stuff with this, with these parameters, quote unquote. But when we're calling the function, right, we call the function print name, but we're passing the argument, right, the string that has my name in it. So that's the difference, basically, when we talk about parameters and arguments. Now, these are usually used interchangeably. Sometimes you might go through a video or read material that calls, right, these as defining the function's arguments. And also, when we're calling the function, we're passing the arguments to the function. And sometimes you might hear them say, we're defining this function, and this is the parameter that the function takes in, and it's going to do stuff with that parameter, right? And then you're going to hear them say, we're calling the function, we're going to pass this string as the parameter. So parameter and arguments used interchangeably, but the difference usually comes in most scenarios. When we're defining a function, this is the parameter. When we're calling that function, we're passing the argument. So hopefully that made sense. Okay, let's define some functions that take arguments. In the function definition, the parameters are defined within the parentheses after the function name. So here we define a function called hello. We specify that the function is going to take in this parameter, right? We're calling this parameter target, right? So this could be anything, right? It could be a string, it could be an integer. We're just telling Python that our function hello is going to accept some sort of external data and do something with that data. In this instance, target is most likely going to be a string. Then we print hello and then target. Calling this function twice like so. Hello, then we pass in our argument Emily, and then we call hello again and we pass in the string world. Prints out two different greetings, hello Emily and then hello world. Let's take a closer look at the function definition. So here we define our function hello. This is the function header. Function name is hello. This is our parameter placed inside our opening and closing parentheses. And then the body of the function calls the print function, passes in the string hello, and then passes in our parameter. Or in this instance, to be semantically correct, since we're calling a function here, we're going to be passing it two arguments, the string hello and our parameter. On the first line is the function header. We define that this function takes an argument and assigns it to a parameter named target. In the body of the function, the print command uses the value stored in target. When the function is called, the parameter target has the value given as an argument in the function call. For example, the following function call. Here we have name, we have a variable name, which is assigned this string, Alan. Then we call our hello function and we pass in that name variable. Right? We pass in Alan basically. Causes the parameter target to be set to the value of Alan. The names of functions and their parameters follow the same principles as the names of variables. They should be descriptive and contain primarily lowercase letters and underscore characters. Again, there are some exceptions to these guidelines, but we will ignore those for now. Okay. Here we have an exercise called the first character, and we're instructed. The exercise contains the outline of the function first character. Please complete it so that it prints out the first character of the string it takes as its argument. We define function first character, takes in this parameter of text called text, and then we're going to have to write the function body. And then here is the main block, right, the if block, in which we get to call that function to be able to properly test that it works. Okay. So down here is where we're going to write the function body. So we need to, whatever string that we pass into our function here, it needs to print the first letter. Just the first letter. So we're just going to say print. In fact, we should probably just do index is equal to 0, print text at index. So now if we do run, all right, we need to indent all this stuff. There we go, get Python. So just be careful. It's not telling us to print the letter, each letter individually here for each string that we pass into our function. Just print the first letter. That's all we want. Print the very first letter. In fact, we just do this. Index at, instead of even defining an index variable, just do print and print the first index, which is going to be 0. We don't have to define an extra variable here, a helper variable to help us do that. So again, if we do that, it still does the same thing. So let's test this. I'm going to close these out. There we go. View the model solution. And they do the exact same thing. Function here is defined. Function body just prints the first letter of our passed string. And then here's where the function gets called. Testing your functions with arguments. Whenever your function takes one or more arguments, it is recommended to test it with various different arguments. Pay special heed to special cases specific to the type of argument you are using. How will your function behave if the argument is 0 or a negative number or a floating point number instead of an integer? What happens if the argument is an empty string? If the exercise assignment doesn't explicitly tell you to include function calls, you may freely include your own within the main function if block as explained above. The tests will ignore everything within the if block. So as you can see here, right, we defined our function here, and the course had already set this up for us, but we're calling the function here a bunch of times with different strings, right? So we pass in the string Python, it prints the P, first letter P, we pass in the string yellow, prints the first letter Y, pass in the string tomorrow, prints the first letter T. So this is us testing that our function does what we want it to do. So it's important that when you're writing functions, just in general when programming, just test your code. Being able to test your code is one of the most important skills to have in programming. And again, it's part of the whole reason why I'm doing these videos as it is, just to help people not only learn Python, but also to know that, to have that fundamental understanding of programming and code. So if you do ever move on to using tools like Anthropic's Claude Code or ChatGPT or DeepSeek or any other of the 40 billion large language models out there to write your code, to write your programs, write your applications, your websites, et cetera, that whatever code is being written for you, that you can skim through it and get an idea as to what the code is doing, so that when you do encounter bugs and problems that you have to fix, that you can go through your code and be able to see what might be causing those problems. Or if you encounter a bug, right, your whatever programming language you're using, you run your program and you get an error, and these, compilers and programming languages are so clever that they will tell you most likely where the problem is. And when you go through and see what line in your code is causing that issue, you can be able to debug it. So that's why we're doing this, right? So being able to test what you write is very important in programming, and I can't stress that enough. All right, so let's keep going. More examples. Let's have a look at some more examples of functions which take arguments. The following function definition, the parameter is a number. Here we define a function called squared. It takes in this, we define this parameter x, and here we print the square of the number x is x times x. So when we do squared, if we call squared and pass in 2, and we call squared and we pass in 5, it prints the square of the number 2 is 4, and the square of the number 5 is 25. Meanwhile, in this function definition, there is an if statement within the body of the function. Here we define a function called hello. We pass in this parameter called name. Then we have an if statement here. We check if name is equal to Emily. We print hello name. Otherwise, we print hi name, right? So for every other case, print hi followed by the name. But when the name is Emily, print hello followed by Emily. So when we do hello Emily, it prints hello Emily. But if we do hello Mark, it just prints hi Mark. Here the function takes 2 arguments. We define a function called sum, takes in 2 arguments, x and y. We have a variable called result, which stores the result of x plus y, and then we print the sum of the arguments x and y is result. We call sum, we pass in 1 and 2. We call sum again, we pass in 5 and 24. And we get the sum of the arguments 1 and 2 is 3, and the sum of the arguments 5 and 24 is 29. The function also includes the helper variable result, which it uses to store the sum of its arguments. Notice how the names of the parameters within the function definition have no relation to any variables outside of it. We might just as well call the above function like this. X is equal to 100, y is equal to 30, sum 1 and 2, sum x plus y and 10. This should print out the sum of the arguments 1 and 2 is 3, the sum of the arguments 130, and 10 is 140. In the first function call, the parameters are assigned the values x equals 1 and y equals 2. In the second function call, they are assigned the values x equals to 130, right, x plus y, and y is equal to 10, regardless of the similar named variables used in the function call. We'll come back to our function definitions in the beginning of the next part of the course. Okay, here they're gonna warn us something here. Warning using global variables within functions. In the examples above, that we saw that it is possible to assign new variables within function definitions. The function can also see variables assigned outside of it. In the main function, such as variables are called global variables. Using global variables from within functions is usually a bad idea. Among other issues, doing so may cause bugs which are difficult to trace. Below is an example of a function which uses a global variable by mistake. So here we define a global variable named, we assign it the string Betty. Then we define a function called hello, which takes in this parameter given name. Then we print the variable instead of the parameter by mistake. So we print hello, but we're passing the global variable name instead of the given name, that the parameter that we want to pass, or the argument that we're going to pass into our function to be used in this print statement here. So when we do hello Steve and then hello Betty, it still prints hello Betty, hello Betty. No matter how many different arguments we call the function with, it'll always print out the value Betty stored in the global variable. So sometimes you may have global variables, right? Variables that our entire program, both inside of function blocks, inside of loop blocks, inside of conditional blocks, can have access to it. And then you can have locally scoped variables that only appear inside of our functions, inside of our loops, inside of our conditional statements, that help us constrain what we do so that we avoid either updating global variables that we shouldn't, or calling global variables that end up returning incorrect information. Here we have an exercise called mean, and we're instructed to please write a function named mean, which takes 3 integer arguments. The function should print out the arithmetic mean of the three arguments. So we define a function here called mean, takes in three integers, a, b, and c. Then we just print, I'm going to use an f string here, and we're going to print a plus b plus c divided by 3, like that. So let's run this. Here we get 2.0. If we plug in 1, 2, and 3, we're going to call this again. We're going to use, in fact, these samples that are already provided for us. So hopefully it gives us 3.0 and 4.0. And we do, we get 3.0 and we get 4.0. So let's test this and see how we do. And we pass. We can view the model solution. And they use a helper variable here called answer. They do the arithmetic, and then they print the answer. Right, we just did it in one go. We just using an f string, print a plus b plus c divided by 3. And again, you see how this is an even better approach, right? So instead of doing a, b, and c, which are a little bit vague, right? We want self-documenting code. So we can do here num1, num2, num3, and then instead of doing a, b, and c, we can just do num1 plus num2, num short for number, and num3 divided by 3. And our code still works, and if we test it, it still works. So when it comes to passing arguments, try to be as descriptive with your argument names. Again, just in the sake of writing self-documenting code. But you'll see me a bunch of times. I'm not gonna hold myself as some morally superior programmer. I'm going to use shorthand. I'm going to use sometimes vague argument names. It's just what it is, just for the sake of learning. But if you ever catch me doing that, just write it in the comments, and I'll be sure to go back and fix that. But yeah, you try to always use descriptive names for your functions and for your the arguments that you pass into your functions. Okay, we have an exercise here called print many times. It says please write a function named print many times. I'm just going to copy this. We see here it takes in two arguments, a string and an integer. As arguments, the integer argument specifies how many times the string argument should be printed out. So when we call print many times high 5, it should print high 5 times. And then here when we print text and times, our text is all Pythons except one, grow up. Times is 3, it prints that string 3 times. So we're just gonna go here, write define, print many times, and then we're just gonna do print. In fact, we should probably use a loop here while I is equal to 0, while I is less than or equal to times, print text, then I plus equals 1. Let's run this. So print how many times? Python 5, 1, 2, 3, 4, 5, 6. So this should be less than, so 1, 2, 3, 4, 5. If we do, we're gonna do this string. Okay, I'm gonna do it 3 times. Right, get it 3 times here. So I think this should work. Let's run this code, test it. There we go, let's view the model solution. And they do this, they define a function, they use a while loop, while time is greater than 0, print. So they use a decrementing loop, we use an incrementing loop, right? We start from 0, we go up to the amount of times. They start from the times and come down. So they print the text and then decrement times by 1, and then they call the function down here in the main block. Usually I like to go this way, just a little bit, we're all used to seeing this formation, but you can also do it this way. Either way is perfectly fine. And you know how I like to do it, I is equal to I plus 1. Just a little bit more legible, but yeah, that's the solution. Let's move on to the next one. Here we have a exercise called a square of hashes. It says please write a function named hash square. I'm going to copy this. Takes in this argument length, which is an integer argument. The function prints out a square of hash characters, and the argument specifies the length of the side of the square. Okay. Define, make sure we have that. And then we're just going to do I is equal to 0. while I is less than the length, print that hashtag times length, then I is equal to I plus 1. If we run this, get 5 hashes here. They did it 3 times here as well, so we'll do that. All right, so we get our 3 hashes here as it does here. We can put an empty print statement here to make it visually close to that. We'll do it one more time. We'll call this function. We'll pass in 2, and it works. Let's test this. Do the model solution. Define a function called hash squares. They use size instead of length as defined here in the instructions. Doesn't matter. We can call our arguments whatever, but again, like I said earlier, try to be descriptive. So here, toes is equal to size. Again, fine, but kind of confusing. You're introducing new variables that are a little funny, but again, if it works, it works, right? I've said it before in the past. There's 100 different ways to reach the same solution. They're printing the hashes here, and then they decrement. So they like to do this decrementing loops, right? I think the incrementing loops are a little bit easier to read and a little bit easier to follow. But our solution, the model solution, so they use, again, they said toes equal to size, and then they use toes to decrement down. So they could have just used size, right? Well, size is greater than 0, then decrement size, but or maybe that might actually, no, I'm sorry, that if you do it this way, then you could, since we're decrementing size, it would probably print out like one less excuse me, I did not mean to open the console log here. Right, if we do here size, and then do size minus 1, I think it's gonna print one less hash per line. Yeah, there it is. So it prints that half pyramid. So that's why they use toes is equal to size and then decrement toes instead of decrementing size. But again, that's kind of just, a little extra step. I think doing it this way is a little bit cleaner, but you can also do it this way. Okay, here we have a function called chessboard. It says, please write a function named chessboard, which prints out a chessboard made out of ones and zeros. The function takes an integer argument, which specifies the length of the side of the board, and then see the examples below for details. So we call it chessboard, pass in this argument 3, it prints out 101, 010, and 101. Call it chessboard, pass in 6, and it prints out this. Okay, so here we're going to define a function called chessboard. It's going to take in a size, I guess, function variable. We're going to have a helper variable here called I, set that equal to 0. We're going to have a loop. While I is less than or equal to size, we're going to have another helper variable. We're going to do a nested loop here, j equal to 0. Then we're going to have a row variable. This is going to be the string that's going to help us concatenate the 1s and 0 to print for each line. We're going to say while j is less than or equal to size. Pardon me. Then we're going to do a conditional check here. If I plus j, right, if the remainder, by dividing by 2, basically if I plus j gives us a positive, an even number, then we're going to concatenate a 1 to our row string. Otherwise, we're going to concatenate a 0, right? So for when it's an even number, concatenate a 1. When it's an odd number, concatenate a 0. And then we're going to increment j by 1. We're going to come and print our row down here, and then we're going to increment I by 1. Let's run this, and there we go. We go, pardon me, something's not right. Why do we get 1, 0, 1, 0? We should get 1, 0, 1. Or j is less than or equal to size. If I plus j, remainder is 0, then concatenate a 1, otherwise concatenate a 0. then we increment j by 1, then we print row, and then we increment I by 1. Okay, what happens if I pass in 2 here? Let's test this and see what happens. Now I printed out 4 rows. So I'm thinking the issue might be because I'm doing less than or equal to. Let's try this. There we go. So now if we pass in 3, it does this. If we pass in 5, it does that. Pass in 6. And there we go. So this allows us to alternate, because if we just do j%2 and run it, it prints the same thing over and over and over. So we need to be able to tell Python, hey, make sure you check, you go up each column and each row and then do the check. So that's why we do I plus j instead of just j, or just doing I, right? Or do the same thing but oppositely. So it prints 1 1 1 0 0 0 1 1 1 and then 1 1 1 1 1 1 and then 0 0 0 0 0 and so on. We need to be able to switch between columns and rows to be able to do to concatenate correctly. So that's why we do I plus j. So if we test this, there we go. You can view the model solution. Again, they have a helper variable called I. Well, I is less than size. Check if it's an even number. So they concatenate this way, right? 1 0 times size, otherwise 0 1 times size. So as you can see from the examples here, we either start with 1 0 per string or 0 1 per string. So we're telling it concatenate 1 0 if it's an even number by the size, or concatenate 0 1 by the size, and then print from the first index of our row string here, from the first index to the size, and then increment by 1. So this is even more concise than our method. Ours might be a little bit easier to follow. We're using nested loops, but this is an even more concise way of doing it. So this is going to print out a very long line, but we just wanted to go up to the length of the size, right? So if we're 3 characters deep, we just want to go from 0, 1, 2, and then that's it. So that's why size will be 3. We're going to go to 0, 1, and 2, et cetera, et cetera. So yeah, this is actually pretty neat. This is a really, really, really concise solution. And here's ours. Okay, I think this is our last exercise called a word squared. And we're instructed to please write a function that named squared, which takes a string argument and an integer argument and prints out a square of characters as specified with the example below. We call it squared. We pass in AB, we pass in 3, and then we do the same thing here with AB, AYB, ABTU with 5. So it prints out a different combinations given the number of letters we provide, right? So if we put in AB and we want 3 different combinations, it'll give us ABA, BAB, and then ABA again. Here with ABABTU, we want a 5 character string and just give us different combinations using the provided characters. So here we're going to define a function called squared. Okay, squared is going to take in a string and it's going to take in times. Then we're going to do index equal to 0. We're going to have another helper variable here called I. So I is less than times. We're going to have our string that we're going to concatenate. Going to have another helper variable called j because we're going to need nested loops. While j is less than times, then what we want to do is check if the index is equal to the length of the string, right? So if we're at the end of the string, right, we're going to use index to track where we are in the string. Normally we use I, but I is a different way for us to increment to loop through the string. I mean, how many times we want to loop. Right, so if index is the end of the string, then what we want to do is set index back to 0, right? So basically, hey, Python, go back to the beginning of the string. Then we're gonna concatenate that position in the string, right? Whatever letter we are at that index, we're gonna concatenate it to our string that we want to print. Then index, we're going to increment by 1. In fact, this would be row is equal to row plus, and then index is equal to index plus 1, and then j is equal to j plus 1. Then we're going to print our string, and then we're going to increment index, I, not index, because we need to loop through the continue looping. I is equal to I plus 1. So when we run this, oh, sorry, can't do that. We have to, I'm going to reset this, sorry. We have to, can't forget, if name is equal to main, then we get to call squared. So I'm just going to copy those examples like so. Let's run this. Oh, not S, we use string. Sorry. Did I use S again? Right. String, just a little bit easier to read. There we go. So when we call squared with AB, we get ABA, BAB, ABA, same as over here. And then AYBAB, TUAB, same thing as up here. We get down here when we pass in this string. So what is our code doing? We define a function here called squared, takes in a string and the amount of times that we want to loop through that string. Here we have a helper variable to help us track what position we are in the provided string. And this is our another helper variable that's going to keep track of how many times we're looping. We have a while loop here. While I is less than the amount of time that we want to loop, we have this variable called row, which is an empty, initialized as an empty string. That's where we're going to concatenate the letters that we're going to put into our output. We have another helper variable because we're going to do double loops, right? Nested loops. And then we're going to do while our second helper variable, j, is less than the number of times we want to loop. Check if what position that we're in the string is if it's at the end of the string, then go back, right? Because you could have different variable length strings. And if we don't want this to continue looping over, say for example here we have a string that's only 2 characters long, but we pass in 3, right? So if we do A, B, if we go in, so 0, 1, and 2, right, it could throw an error. So we're telling, hey, if we reach the end of the string here, go back, right? Set index back to 0. Then we're going to concatenate that position that we're in the string. So that's why we're getting string passing the index. Then we're going to increment index by 1. So if we're at position 0, we're going to concatenate that A to our printout. So we're here. Then we're going to go forward, concatenate the B. And then we've reached the end of the string because it's A and B, so we're going to go back. And then we're going to concatenate one more time because we have to loop 3 times. Okay, then we increment J by 1. Then we print out our output. Then we're going to increment I by 1. So so that would be our first loop. Then we'll go through in and print this. Then we'll go in and print this, and that would be how many times that we've looped through to come up with our output. And now here's what we call the function. So that's what we're doing. So let's test this and see how we do. If you have any questions, if you're still a little confused, let me know. I could come back to this exercise. And again, they did it again so much more concise. Have a helper variable here called I, helper variable for row to print out our concatenated string. While I is less than the size, right, how many times we want to loop by, squared. If I is greater than 0 and I is a even number, or if the index that we're in is even, then we print the row. Okay, what's the? I forgot the link, but I want to see this. If name is equal to main, then we're going to call squared, pardon me, AB3. See how this, oh, sorry. So it does the same thing. What was give me 1 second. Right, this is what I wanted to get to. The visualizer that we've used in the past. All right, so this is what I wanted to go over. I just wanted to run our solution into the Python tutor code visualizer. Link will be in the description. If you haven't bookmarked it, you should bookmark it. It's a really good tool just to help you track what your code is doing. It also works with other languages. So if you're learning Java or C or C++ or even JavaScript, you can use this tool. And when we move on to the future, we start doing other programming languages like Java, like C++ or JavaScript. I think we're going to be coming back to this tool a lot. So I pasted the code in here. This is our solution. And I know visually when you're looking at the solution, it might be a little difficult to, follow along. But I think this might help us just to really keep track and see what Python is doing while our code is running. So Python text is going to be 49 steps to execute this code from start to finish, granted with this input. So, let's give this a go. So when I hit next here, you're going to see that the arrow that tracks the next line to execute is going to come down here. Now remember in our notes, right, when we were reading here, we had to do if name, right? Because this is where our functions are going to be called. So we have to write this if block statement that checks whether or not our function is being called in the main block. So that's why we're coming down here. We're going to skip everything here. Python doesn't need to run this first. It's going to come down here and check, hey, we're declaring that we're in the main block, and then, or we're checking if the current name of our file or where our code is going to be run is in the main block. And if it is, then call the squared function. So when I click next here, the visualizer is going to put the next line to execute down to the squared function. So you can see here the global frame. We're now calling this function called squared. Squared takes in characters and it takes in a size. These are the two parameters that the function is defined with up here. So when I hit next, now Python comes up here and it says that, hey, we called square. For characters, we're passing in the string AB, and for size, we're passing in 3. So this is where we're putting AB, and this is where we're putting 3. So squared is called, initialized with AB and size 3 for the arguments. Then we go inside squared, and we are declaring this variable I, which is assigned an initial value of 0, an integer value of 0. So you see it here also, right? It's tracking I. Then the next line to be executed will be this one, where we declare this variable row, which is going to be initialized with an empty string. You can see it come down here. So row is an empty string. And then we have our while block that's next, where it's going to ask while it's checking while I, this variable, is less than size times size. So in this instance, size is 3, so it'll be while I is less than 3 times 3, or while, in simpler terms, while I is less than 9. We're going to go inside here. We have a nested if statement, which checks if I is greater than 0 and then the remainder for the division of I and 3 is 0. Now, I is currently 0, so is I greater than 0? It's not. I is currently equal to 0. And so 0 divided by 9 is not is 0. So this does work, but remember we have this AND operator here, which means both sides of this if statement have to be true. So this is true, this is false, while this is true, so this is false. So it's not going to run anything inside this if statement. So it's going to skip this print row. It's going to skip setting row to an empty string again, and it's going to come down here. As you see, this arrow is going to come down here to line 8. So now row plus equals characters I divided by the length of the characters. So we know that the length of the characters of AB is 2. So we're doing 0 divided by 2. Take that remainder and set that, and basically take the current character and append it to the row variable. So now row is going to have that first character A. So you can see row now has A, and then we're incrementing I by 1, so this is going to become 1. Now we're coming back here. We're still inside the while loop. Now we check while 1 is less than 9, right? We're going to check the if statement. Is 1 greater than 0? It is. And is 1 divided by 9 equals 0? And no, it's not, because that returns a decimal number. So we're going to come down here and append the next character in line. So it's going to append B to our, I'm down here to our string. So now it becomes AB, and then we print, and then we come back up here. Now I becomes 2, right? Is 2 less than 9? It is. We check the if block here. So it's just going to keep doing this over and over again, and it's going to append A again. And then now I is 3. Is 3 greater than 0? Do that division, right? 3 is greater than, now why is this now executing inside? Because both sides here are now true, right? Because 3 divided by 3 doesn't return a remainder, right? It returns 0. So now we print the whole row, and we set row back to an empty string. So we print first ABA, we reset row to an empty string like how we first initialized it, and then we're gonna append that empty string. It's gonna set this now, because remember, part of the reason we have to run this multiple times, and because we have to also make sure that we don't run into end of string errors. So now it's basically gonna reset the string and do it the other way. So now it's just gonna keep running. It's gonna be B, run again. It's gonna be BAB, and then it's gonna reset to an empty string, or it's gonna print it, then it's gonna reset to an empty string, and then it's gonna run again. And it's gonna print ABA one more time. And then that's it. So that's our final line. So hopefully that made it a little bit easier to follow. But yeah, part of the reason why we're doing this way is because we have to also make sure that we don't run into end of string errors or index out of bound errors. So when you do it this way, when you check the position against the size, so we can make sure that we loop back to the beginning of the string. Anyways, hopefully that made sense. I think this might have even been confused, being a little bit more confusing than I originally thought. But if it hasn't, I hope that you find this video helpful. We did the last exercise in section 3, in section 4 of part 3. So everything here is done. Solutions will be up on GitHub if you just want to skim through them and you don't want to sit here and watch this very long video. There's a questionnaire here on the bottom. Again, I've said this in the past. If you have the time, just submit it. It's very helpful to the instructors who put this course together to get some feedback from people who are taking the course, to find out what's easy, what's difficult, how to improve the material moving forward. So yeah, I think everybody should do these feedback quizzes. So the next video, we're going to be starting part 4, section 1 of part 4. And like I mentioned at the beginning of the videos will now be more long form videos, where in one video, we'll go through an entire section. We'll do the exercises in those sections and, things that basically pertain to an entire section rather than dividing those sections into smaller videos, right? Well, we can do one video for one section instead of doing 3 or 4 videos per section. So I think that might be a little bit better moving forward, and I think that's what I'm going to be doing for now. So the next video will be the entirety of part 4, where we set up the Visual Studio Code editor, a Python interpreter, and whatnot. So I think moving forward here, we're going to be moving off platform or off the website, where we're going to be writing our solutions in a dedicated text editor instead of doing them in the website. But I could be wrong. So I'll take a look at that off screen. But the next video will be, the entire video will be focusing on section 1 of part 4. We have 6 sections to cover here. If you have any questions of what the material we covered in this video, let me know in the comments below, and I will be sure to try and get back to you. If you found anything confusing, let me know. I'll make another video or respond to you in the comments as best as I can. But yeah, we're about to be halfway through the course, and so that's why I want to change the length of the videos to be longer so that we can go through the material a little bit quicker. Maybe do one video a day going through the material. So hopefully maybe in another 2-3 weeks we'll be done with part 7. And if you are able to take the quiz, get your certificate of completion, I'm going to try and do that as well and give you guys feedback on what the quiz was like. The exam. I shouldn't call it a quiz because I'm making it sound a little too trivial. But I'll take the exam and see how I do and come back to you guys with some feedback about that for anybody who actually wants to take the exam but is feeling a little nervous. So again, if you have any questions, leave them in the comments below, and I'll see you guys in the next video.